Now example B is asking us to find the equation of the line of symmetry, find the coordinates hk of the vertex of the parabola y equals x squared plus 3x minus 5, which is the same equation that we had up above in example A. Then we are going to write the equation in the form y equals a times x minus h squared plus k, which is called vertex form, because it shows us where the vertex is. Now, the line of symmetry always goes down the center of our parabola. And because of that, it has to pass through the vertex, which is at negative 1.5, negative 7.25. Okay, and you can find that by graphing it and second calculate maximum if it's opening downwards, or second calculate minimum if it's opening upwards, like our equation here is. So you might want to give yourself a reminder: vertex, second calculate minimum. And our zeros we already found from the front side of our notes. Since we know the line of symmetry has to pass through the vertex, the line of symmetry is just x equals whatever the x-coordinate of the vertex is. So our line of symmetry here is x equals negative 1.5. Now we did take it a step further here and find the vertex, but if you're not given the vertex, you can still find that line of symmetry using just your x-intercepts or your roots. To find your line of symmetry, if you don't have your vertex, you take your two root values, you add them up, and you divide by 2. The reason you can do that is because that line of symmetry has to be halfway between the two x-intercepts, since we know that a parabola is symmetrical. Then, once you have your x value here, that's really your h or your x-coordinate of the vertex, and then you can always take that value in and plug it back into the original equation to find y. Okay, but now we have enough information here to write our equation in vertex form. Now the only thing we haven't talked about yet is a, or our stretch value, but we can tell what that stretch value is just by looking at our original equation. If there is a stretch value out in front of x squared, that's going to be the same value that's out in front of our parentheses. Since here we have nothing out front, or you can think about it as a 1, that means we have a stretch value of 1. So now our final equation is going to be y equals, and we can put the 1 out front or we can leave it off, and we have x minus a negative 1.5, which would be a plus 1.5 squared, plus our k value, which is a negative 7.25. So there's our equation, and down here was the line of symmetry equation. Now, you can always check your work by graphing your new equation compared to your original equation, because all we were doing was rewriting the original in another form, so it should be the same exact graph. And sure enough, if you graph both on the same graph, you just end up with one parabola, which means one is tracing on top of the other. And you can look even further at our table here. For every x value, both of the equations give you the same y value. That means that they're the same exact equation, they're just in different forms. Now go ahead and try the guided practice, and then watch the next video to check your work.